Hey guys, this is a tutorial of how to make a mechanical accelometer using basic material and some of our engineering skills. This is a part of our project for engineering measurements at the American University of Sharjah, the mechanical department, and it's presented to Professor Bassam Abu Nawa. Now we're going to move to our computer, we're going to show you how to make the design on Inventor, then we're going to move to the design of the actual piece that we need to do. Alright, so basically using Inventor, this was our theory design, which was having a cantilever beam in the center which enters from the side and then having the casing above it. And we apply the mass on it and we will show you the assembly in a moment. Alright, so basically this is the concept design that we have came up with, and basically we're going to show you the stress analysis. What we have done is that we have applied force in the tip of the cantilever beam, and we're going to simulate it to see the maximum von Mises stress. If you can see that there is a little bit of deflection happening in the end of the beam, and here 10.11 almost is the maximum von Mises stress that we have examined. And here you can find our final design. Here is the casing, these screws. Let me show you a better view of this screw. This screw is a T10 sized. The mass is here. The mass is basically, it's just a rod of steel, and we cut the rod of steel with a thickness to get 2 grams of mass. And then we have the cantilever beam right here. It's we use the feeler gauge, and a feeler gauge is basically there are slices of metal to actually figure out the clearances between surfaces, such as the spark plug clearance. And this is about it, and we will show you a video right now of the, see, the cantilever beam goes in and then the mass, and then you screw it with the 4 screws, T10, and that's about it. Alright, so basically what we have done is that we have went to the engineer in our labs and we have asked him to design this to us, and here is the casing, here is the cover for the casing. The feeler gauge, it's 15 millimeters, and we have cut it in this shape, in the L shape, as you guys can see. And we've made sure that once it goes in, it goes in, and then it doesn't touch the end of the, I don't know if it shows, but there is a clearance here that you guys can see. It doesn't touch the end. So basically what we have to do is now we have to glue this. We're using super glue. Just applying a little bit of super glue, holding it in. You have to keep it tight for a couple of seconds, and then we have to do the same procedure, putting the mass right here. So the final shape is gonna look like this. Now what we're gonna do is we're gonna apply some super glue here. We're gonna apply the mass and hold the mass as well right there. So I think this is done. So we're just gonna keep the mass for a couple of seconds. You guys know that super glue does not take a lot of time to process, and it's almost done. Now what we have to do is just put the cover on the casing, and I'm gonna screw the T10 4 screws in their location. I'm doing it with my hand because it's faster. Mechanics will understand me. And using this screw to tighten them. And that's about it. There you go. It's right there. Now the strain gauge is what it's gonna take the measurements, and it's gonna put it on an Excel sheet, or it's gonna put it on LabVIEW or whatever you guys are gonna use it on, and we place the strain gauge right there. There's a hole here. We didn't make it, but it's here that you can take out the wires from. Put the strain gauge right there, the wires from, and then connect it to LabVIEW. And this is basically the accelerometer. Thank you guys for watching. Here's our little accelerometer. If you guys have any questions, please do not hesitate to email me at b0004639 at aus.edu.